In this video, we discuss some algebra of infinity, negative infinity, c is a constant, right? Where c here is a finite number, so that's a constant. This doesn't follow the algebra rules we know before, right? So what's the meaning of this infinity here? Just means we have a function getting larger and larger without upper bound. Negative infinity, that means we have a function getting larger and larger negatively without lower bound. C is a constant, zero, we know it's zero, right? If zero is in the denominator, that means you have a function is getting closer and closer to zero. It doesn't mean that's dividing by zero, right? So write down an example here, what we mean by infinity minus infinity, right? What's the meaning of that? This just means this is a shortcut, a notation for this difference of two functions. X goes to somewhere, let's call that A. A could be infinity or could be negative infinity, right? F of X minus G of X with both the f of X and G of X go to infinity, right? With as X goes to A, f of X equal to positive infinity, and as X goes to A, G of X equal to infinity, right? So that's basically what's the meaning of this infinity minus infinity, right? In our whole discussion, infinity minus infinity just means the limit of a difference of two functions, and both terms go to infinity, right? And some other algebras, right? Infinity plus infinity, that just means a limit of two functions, a sum of two functions, both functions go to infinity. Now we know that this is clearly infinity because getting larger and larger in the same times. So for sure, their limit is infinity, right? And infinity minus infinity, this is undetermined. Undetermined. So that depends on the function form, f and g, right? Sometimes you get infinity, sometimes you get zero, sometimes you get negative infinity. So it could be any number you can imagine, right? And if you have c over infinity, this clearly is zero, right? Because c is a constant, and denominator is getting larger and larger, larger and larger. So the reciprocal is getting smaller and smaller, multiplied by c still very small, right? So this is no. And two more things. So if you have infinity over infinity, so this is also undetermined. Determined. So again here, if you want to know what's the limit of the quotient, you have to figure out a way to handle their quotient, simplify that. I eventually get what's the limit. And this is undetermined. And what else? If you have 0 over 0, this is also undetermined. Undetermined. Right? Basically, if you have a infinity over infinity or infinity minus infinity, and somehow you have to use algebra to make it a new form such that we can apply our fundamental elementary fact, right, or limit laws to figure out what's the limit, right? Let's see an example here. Let's see an example of infinity minus infinity, right? So example, let's see, as x goes to infinity, square root of x square plus 1 minus x, right? What's the limit of this? So okay, what's this, right? Now you can see that as x goes to infinity, square root of x squared plus 1, imagine that. Sometimes you do have to think about plugging positive numbers, x getting larger and larger. This for sure goes to infinity, right? And the second term also is x goes to infinity, right? This is clearly a limit which is undetermined form, right? So in the undetermined form, which is infinity minus infinity. Now, how do we do that, right? So we cannot plug in infinity, right? If you could, you can only plug in finite numbers, right? If the output is finite numbers. How do we do that, right? So one way to do that is clearly we want to use a conjugate, right? So we want to change this to something we are better at, right? What's fractions, right? Conjugate square root of x squared plus 1 minus x, square root of x squared plus 1 minus plus x over square root of x squared plus 1 plus x, right? And so this is equal to as x goes to infinity. So this is what numerator is 1, right? 1 over square root x squared plus 1 plus x. Now you can see that we change infinity minus infinity to a form which is 1 over infinity, right? By our discussion above, this is just a 0, right? Because a finite number over infinity must be 0, right? Okay. So now let's see another example, right? Another very similar example 1 here, and example 2, right? Let's see another very similar example as x goes to infinity, square root of x squared plus 4x minus x, right? Looks not much different, but the answer will be kind of different. So this is infinity minus infinity as we can see, right? So you can see that we want to do the same thing, right? If you have infinity minus infinity, you have a square root. Think about conjugate, right? So it's equal to as x goes to infinity, conjugate, you get a square root of x squared plus 4x minus x, square root of x squared plus 4x plus x over square root of x squared plus 4x plus x, right? So this is equal to as x goes to infinity, try to do the multiplication, you get 4x 4x over square root of x squared plus 4x, then plus x, right? Now, if you look at the numerator, right, as x go to infinity, so this is clearly infinity over infinity, still undetermined, right? So by our discussion before, we want to change the infinities to 0, right? Or a finite number by making a division of the infinity, right? We choose the biggest power of x, right? And so this is x order 1 here, order 1 here. This x squared is order 2, but we take a square root and go back to order 1. So clearly we want to multiply by 1 over x on the numerator and denominator, right? 4x times 1 over x over square root x squared plus 4x plus x times 1 over x, right? Make sure nothing changes. So we make a division by x on both numerator and denominator, right? Now let's try to do this. So this is as x goes to infinity, you get 4 over 1. Now the first term here, we want to put 1x into the square root. If you want to put something into the square root, you need to square it, right? So if you have x is a positive, then 1 over x is basically square root 1 over x squared, right? So that's how do we put something into a square root. So you get 1 over x squared times x squared plus 4x, right? And so this is as x goes to infinity, 4 over square root 1 plus what? Plus 4 over x and plus 1, right? So now you can see that if you look at the limit of each term, this term here is 4 here, this term here is 1 here, this term here goes to 0, this term is 1. So everything is finite number. And if you plug in the number, you don't have 0 in the denominator, so everything is good. So the answer is 4 over 2, which is 2. So that's the limit of this function here as x getting larger and larger without upper bound goes to infinity, right?